Good evening, children. Happy Onam once again. Yes. Now, once again, I want to repeat the same thing. That means the children should learn the theory, the concept, what all things, the topics given in your textbook. Read the textbook very well so that you can answer any type of questions. And don't worry about it. It is MCQ, you won't get them. No need. You have to study. You have to give some pain for that. Then you can score better marks. You can win. Sure. Now, let us move on to the case study. Third case study for electromagnetic induction and AC, the fourth unit. Please like, share, and subscribe this 1 mark solution. So let us begin with the case, which is the case we are going to deal with. You can see a figure. That in the figure, a metal rod PQ, you can see a metal rod PQ like this, the metal rod will be there. Then blue shades, we can see that resting on the smooth rails AB, resting on the smooth rails. Two rails are there, this light blue shade rails are there. It is so this is placed between two rails here, and we can say that a permanent magnet. Where it is placed, all the things are placed in the permanent magnet. And north and south, we can just say that is a horseshoe magnet. It's just like a horseshoe magnet. Horseshoe magnet units, powerful magnet. That means if you want to get the magnetic field, that means maximum magnetic field, you can use the horseshoe magnet. Just like the horseshoe. Don't think about that horse is wearing the shoe. That name of the magnet, we can say like that. Then the rails, the road, and the magnetic field are in three mutually perpendicular directions. Which are the things? The rails is in this manner, magnetic field in this manner, and what is it? The magnetic field. This is the magnetic field. You can see this is the magnetic field, and we can say the rails, isn't it? The rails we can say in this manner, right? And the magnetic, what is it? The road is in this manner. I think you can see that, isn't it? So all these are perpendicular. X, Y, Z, we can say. If this is Y, X, and Z. Like that. Three mutually perpendicular directions. A galvanometer G connects the rails to a switch K. One more thing is also there. A galvanometer G is connected between the rails. What is the use of a galvanometer? To detect the presence of current. Where there is current is there, the galvanometer shows a deflection. If there is no current, galvanometer shows zero deflection. That is the thing you should know that. So here if you are connecting galvanometer means what is it? If there is any current in these rails, the galvanometer shows a deflection. So from that we could understand that there is a current. Now with the switch is also there. If you need it only, we have to just on it. Then we can say what all parameters are given there. The length of the road is given 15 centimeter, okay. And we have to convert. When we are doing it, you have to convert into meter. Why? Because we are following SI system. You know that SI system is very important. So system international unit. B, magnetic field is 0.50 Tesla. Tesla is the unit of the magnetic field. Resistance of the loop, closed loop containing the road is also given. 9.0 milliohm. Small letter M stands for milli. You can see that small letters M stands for milli. If it is capital letter M, mega. Milli means 10 raised to minus 3. We have to add. Assume that field to be uniform. We can just assume why? Because it is already in this magnetic field. So we can assume that this is uniform. That is magnetic field is uniform. So let us move on to the questions. So here we can say, suppose K is open. You can see this key here. K, it is written K here. This K is open now. Open means it is not connected. If it is K is open and the road is moved with a speed 12 centimeter per second. If they are having a speed of 12 centimeter per second in the direction, what is the direction shown here? It is towards right side. Now, the question is, give the polarity and the magnitude of the induced EMF. Polarity means what is it? You should know where is positive and where is negative. Or you can say the direction of the current also. So first we have to find the induced EMF. What is the equation for induced EMF? We will call it as motional EMF. That is also very important. E is equal to BLV. We can study in that manner, BLV. And that is the letters it is here, where V stands for velocity, B stands for magnetic field, L is the length of the road. So here we can say V is given as 12 centimeter per second. That is 0.12 meter per second. Then you have to multiply by B. B is given as 0.50 Tesla. So you can see here 0.50 Tesla into 0.15. What is it? 0.15. You can see 15 centimeter. Length L is 15 centimeter. So you have to convert into meter. So 0.15 meter. So if you are multiplying all these things, 12 into is also there, 12 into 0.50 into 0.15 is equal to what you are getting actually, 9.0 millivolt. What is the unit of EMF? Volt itself. So 9.0 millivolt. Milli means what is it? 10 raised to minus 3. So you will get the answer 9.09 into 10 raised to minus 3. Actually, you will get in the volt, 9.0 into 10 raised to minus 3. We are just writing millivolt. If you are writing volt also, no problem. You will get the mark. Don't worry about it. Now, options are given anyway, so you can just click it. Now, we can go for what is the polarity. Polarity means direction of the induced current. The rule which is used for induced current is Fleming's right-hand rule. Fleming's right-hand rule, you know that these fingers, forefinger, middle finger, and thumb represents the, what is it? Yes, represents which all things we can say. This stands for, the forefinger always stands for magnetic field, and the middle finger induced current, and the thumb gives the direction of the force. So you can just place it. Your fingers, you can just place it in this figure. You can see this figure. What is the magnetic field direction from north to south? So you can place it like, keep it like this. The finger, this finger, forefinger. Then what is the direction of the force? It is moving in this manner. So you can just keep it like this. So what is the direction of the current? You can say this is the direction of the current. So from this, that is Fleming's right-hand rule is used for finding the induced current. So the P will be positive and Q will be negative. So that is the answer. Polarity. What is the polarity? You have to say. Now we can go for the next question. Second question. Is there an excess charge built up at the ends of the road when K is open? You have, I will just show the figure once again. Why? Because from the figure only you can understand what is it. If the key is not open, what do you mean by that? Anyway, the charges will be produced there. Potential difference will be produced. Why? Because we know that this road is inside the magnetic field. And if the road is moving, an EMF is induced there. If there is any change in magnetic field, induced EMF will be there. So due to this induced EMF, there will be some charges. So that is a question here we can say. Suppose K is open and the road is moved. Just a minute. We have going for this one, isn't it? Yes, B. Is there any excess charge built up at the ends of the road when K is open? That means sure the excess charge will be there. No doubt at all. Potential difference will be produced. Then what will happen if K is closed? If K is closed, what will happen? The circuit is closed and the charge will be flowing through the circuit. So a continuous flow of current will be there. So that is very important. When K is open also, the induced EMF will be there. Charges will be accumulated there. If it is closed, the continuous flow of current, we will get it. Now let us move on to the next question. With K open and the road moving uniformly, you just think about, they are moving uniformly. There is no net force on the electrons in the road in the PQ. Even though they do experience magnetic force. You have studied that when an electron is moving inside a magnetic field, they will experience a force. We'll call it as magnetic force, QVB sine theta. That is the equation. Then one more force is there. What is that force? We can say electric force also will be there. That is minus E into E or Q into E we can say. So both the forces are there even though they do experience magnetic force due to the motion of the road explained. That means the question is, if with the K is open, there is no net force on the electrons. The question is, there is a road is there, PQ. In the road, there is no net force. Why? Net force on the electrons. Why it is like that? Why? Because already magnetic force is there and one more force is there, electric force. They will be cancelled because due to the excess charge of opposite signs at the ends of the road. We know that from P we got positive and Q we got negative. So there is an opposite sign is there. So that is why these forces are just cancel each other. So there is no net force. So now we can go for the next question. What is the retarding force on the road when K is closed? What is the retarding force? Retarding force. Anyway, force you know that. Force on a conductor carrying current which is placed in a magnetic field. Equation is ILB sine theta. Or you can use, you can just recollect BIL. BIL, BIL. You will recollect it. Sine theta is also there. Here in the first condition, we have discussed that all the three are perpendicular. That means 90 degree. So theta is 90, sine 90 is equal to 1. So what is the retarding force? We are getting maximum force ILB. I is there, L is there, B is there. And I is given. I is given, B is also given, and L is also given. So you will get the answer. What is the answer? You are getting the 75 into 10 raised to 3 Newton. That is the answer. How you got it? I, B, L, B. I is not directly given, but I we can find using E by R. What is E by R? What Ohm's law? We can use Ohm's law. Ohm's law means I is equal to V by R. V is equal to IR. From that equation, I is equal to V by R. Instead of V, we can say 9 millivolt. And the resistance given 9 milliohm. So the milli and milli will cancel it. 9 by 9 will get 1. So 0.5 into 0.15. 15 into 5 you will get 75 and 3 decimals are there. So that is why we can say that what is it? 75 into 10 raised to minus 3. Okay. Then 75 into 10 raised to 3 Newton we are getting. Newton means what is that? The unit of force. Now we can go for the next. How much power is required by an external agent to keep the road moving at the same speed? Speed is 12 centimeter per second. When K is closed, how much power is required when K is open? What is the equation for the power actually? Power is equal to F into V, force into velocity. That we have studied it. So power expended by an external agent against the above retarding force to keep the road moving uniformly at 12 centimeter per second, we can say first you apply what is it? Force into velocity. Force is given here and the velocity here 12 centimeter, you have to just convert it into what is it? Meter. So 12 into 10 raised to minus 2. So you will get the answer 9 into 10 raised to minus 3 watt. That will be the answer 9 into 10 raised to minus 3 watt. When K is open, no power is expended. No power will be expended if it is open. If it is closed, then only the power we are using it. How we are using it. Okay. Now we can go for the next one. How much power is dissipated as heat in the closed circuit? What is the source of this power? Here we can say power P is equal to I squared R, we can use it. Or the same power. What is the power you got in the previous case? We can use it here. 9 into 10 raised to minus 3 watt. That is the power we got it. The same power here it will be dissipated as heat. And from where we are getting this source of this power? We can say the source of the power is the power provided by the external agent as calculated above. That means we can say that how we can push it, how we can push the road. I will just show. One more thing I want to say, children. You just note this here. It is 10 raised to minus 3. Okay, minus some, how it is gone up. Actually, it is 10 raised to minus 3. Why? Because you know that 5 into 15, 75. 3 decimals are there. 3 decimals, we can put it as minus 3. Okay. Why? Because otherwise you will be confused. 75 into 10 raised to minus 3 is here. And here also we are using 75 into 10 raised to minus 3. Then only you will get this answer 9 into 10 raised to minus 3 watt. Okay. Now, I'm just showing the figure once again, Why? Because you should know that the source of the external power from there, when if you want to move this road, we have to apply a force. So that is why at the last we are telling the source of this power should be some external agency is there. Okay. So I think it's clear. Now you can see that the last question, I'm just pointing out once again, the source of this power is the power provided by the external agents as calculated. I think by this we can just come. One more question is there. What is the induced EMF in the moving road if the magnetic field is parallel to the rails instead of being perpendicular? That means now it is perpendicular. The rails and the magnetic field is from north to south, and the rails is like that. So they are perpendicular. It is like this. Perpendicular. It is like this. Perpendicular. So if it is parallel, what will happen? No induced EMF. Why? Because you know the equation theta is equal to 0. Either you can say theta is equal to 0, sine 0, 0. Or we can say in another manner, the motion of the dot does not cut across the magnetic field lines. If the magnetic field lines are like this, and the road is also like this, they are not cutting it. Cutting means there is no change in magnetic field lines. If there is no change in magnetic field lines, there is no induced EMF also. So that is the correct explanation for this. And one more thing, you can, if you want, you can just note this one. The length of the PG has been considered about to be equal to the spacing between the rails. That you have to note it. The length of the road, that road is given there. That you have to be very careful that it should be about to be equal to the spacing between the rails. So anyway, I think it's clear induced EMF is very important. You should know that when the induced EMF will be there, when the EMF is induced, whenever there is a change in magnetic field, an EMF is induced. Now, thank you for watching. Thank you.